In algebra, for the most part, notation describes three very different types of objects. First, there's an expression, which is notation representing a number. For example, 10 is an expression, 2x plus 4 is an expression. There's an equation, which is a statement that two expressions are equal. Notice that an equation actually talks about expression twice, right? Because there's two expressions. An equation, by the way, has an equal sign in the middle. For example, 1 plus 2 equals 3 is an equation, and using the two expressions from earlier, 2x plus 4 equals 10 is an equation, and this equation just happens to have a variable called x in it. The third type of thing that we see a lot in a notation form is a function. And a function is a rule which provides exactly one output for each input. One way to describe a function, here's the one that looks like notation. It's f of x equals 10 minus x squared. This is a little problematic, I know, because we just said that an equation has an equal sign in the middle, but this is the one exception here. See that equal sign? We'll say that this, when you see f of x, the marker is you'll see a letter, typically f, maybe the next letter in the alphabet g, and then a left parenthesis, and then an x, and then a right parenthesis. When you see that in an equal sign, this is the one exception. This is a function and not considered an equation. Take a look. These are all notation, right? These are all written using symbols, kind of the typical thing that people out in sort of everyday land would call all these things equations, but they're not, right? So 2x plus 4 is an expression, not an equation and not a function. 2x plus 4 equals 10 is an equation and is not an expression and is not a function. And finally, f of x equals 10 minus x squared. That's a function. It describes a function. It is not an equation. It is not an expression. These three things are all different. They're different kinds of creatures. There's expressions, there's equations, there's functions. Three different things. Neither is, all of these three things are different, and it's important to keep track of these three things as being different. The one that's probably least familiar is a function, and so I would like to get you as familiar as possible. And we won't visit all three things every day because that would be a lot to deal with, but we will, every week you'll see each of these three things. So here, f of x equals 10 minus x squared. The way to say this or think, here's an important habit, is when you see math written down in symbols, it's important to think about it correctly. Say f of x equals 10 minus x squared. Don't say fx. Include that word of. That is really key. Say it's worth it. It's really worth saying that word of, because sometimes people will accidentally think multiplication otherwise. So though there's an equal sign right in the middle, right here in f of x equals 10 minus x squared, we're going to call this a function, not an equation. So this is the one exception that we have to the motto that only equations have equal signs. F is the function name. X represents the input, and then after this equal sign here, 10 minus x squared, that is the rule describing the output. So what's f of 3? It's 10 minus 3 squared. Basically, take what's up here, replace both x's with 3's, right? So just stepping back, yeah. So f of x, there's an x right there, that got replaced with a 3 down here. 10 equal sign copied, 10 copied, minus sign copied, x squared. Well, the x here got replaced with a 3, and then the squared, we just wrote that. And then let's go ahead and simplify. 10 minus 3 squared, it's a number. Let's just really see what number it is. So following the order of operations, that's 10 minus 9, which simplifies to 1. In summary, now we showed all this work, which is helpful to see how this part, especially this 10 minus 3 squared, was connected to the 10 minus x squared up here. But in summary, sometimes this work gets in the way. So f of 3 equals 1 here. So in summary, f of 3 equals 1. And that's how we say this. F of 3 equals 1. Let's put this in words. When the input is 3, the output is 1. F of 5 equals 10 minus 5 squared. That simplifies to 10 minus 25, which simplifies to negative 15. In summary, our notation is f of 5, that's this part, and then skipping all of these things between all these equal signs, finally equals negative 15. We say f of 5 equals or is negative 15. In words, when the input is 5, the output is negative 15. On this slide, we have one function. So just to clarify, we're going to take a look at another function as an example in a moment, but this is one function, not two. So f of 3 equals 1 and f of 5 equals negative 15 describe what outputs you get for inputs 3 and 5 for this one function. A function, just to remind you, is a rule which provides exactly one output for each input. right? So when the input was 5, what was the output we got? Negative 15. That's the only output. We didn't get more than one output. That's the only output when the input is 5. Just like over here, the output was 1. We didn't get any other output. 1 is the only output you get when we're thinking about input 3. Here's another function. G of x equals 3 plus x times 10. So say the word of. The key word here is to think of. G is a function or a rule. That is, when you input this thing called x, you get 3 plus x times 10 as output. So for instance, G of 6, take a look up here. The x that was here got replaced with 6. The x that was there got replaced with 6. Otherwise, the rest of this line was copied directly down here. Here, let's follow the order of operations. That's part of the reason why this looks as funky as it does up here. It's 3 plus x times 10 to make the point that it would be incorrect to do 3 plus 6 first. The order of operations still applies. Read this using order of operations. 6 times 10 first is 60. And I still wrote, to make this truly equal, I still wrote the 3 plus. Had to account for it. And now what's 3 plus 60 equal to? Well, that is equal to, write an equal sign here, not an arrow, 63. So in summary, G of 6 equals 63. When the input is 6, the output is 63. G of negative 10. So let's plug in a negative 10 for each x. So 3 copied plus copied. X replaced with negative 10. Times sign copied. The 10 that's here copied. Right? So I know it looks like there's two 10s here, but one of the 10s was just copied up from the formula for G. The other 10, it's actually a negative 10, was because here the question was G of negative 10, and then simplify using the order of operations down to get to negative 97. So G of negative 10 equals negative 97. Here in words, when the input is negative 10, the output is negative 97. Writing G of negative 10 equals negative 97 is correct. Writing G of negative 10 equals G of negative 97 is incorrect. What's the key difference? Take a look at what's in red versus what's in black. The difference here, notice where my mouse is pointing and where I'm circling, there's this extra G. That G is no longer there. So what's this first G about? I should point to the correct work here. This is a process, right? This is a rule. It's a machine. We fed in this input negative 10, and we're reporting on what that output is. It is negative 97 here without a G. If there were a G, this is trying to suggest that we take negative 97 and now make that number serve as the input and refeed that back into the machine. But that's not what we're doing here. Again, a function is a rule which provides exactly one output for each input. So just to clarify what do we mean by function as a rule, in writing up at the top, G of x equals 3 plus x times 10, this part right here, this 3 plus x times 10 part, that's what describes the rule. The rule is what tells us how to take an input, which is called x here, and produce the corresponding output, or provide the output, or compute what the output should be for that input, so get the corresponding output. So this is the interactive question. Be sure to go answer this thoroughly and online. Identify which of these, so all 7 of these samples that are written down are in notation form, but which are expressions, which are equations, and which are functions.